Okay, this is grade 7, Introduction to Linear Relations, chapter 10.1. These are the questions that were selected from the textbook, Lucy, for you to answer. If you don't know how to do some of them, that's okay. Just pay attention to the answers, and if you want to go over it later on and watch this YouTube video, you can. Just fast forward to the part you had difficulty with and listen to it a second time. So the first question says create a pattern and use either shapes or numbers. So I'm going to make this shape here. There's shape 1. Then number 2 is going to be adding 2 circles to it. And then the third shape, I'm going to take that, I'm going to add on 2 more circles. And then I have number 4, sorry. I'm going to take that shape right here and add 2 more circles onto it. And that's where I'm going to stop. So what we have here is, it says write your description in words. So what I'm going to do is, in words, start with 1 and add 2 each time. So in words, I can say something like that. All right? And then you can compare with whatever you want with the other things. I'm not going to compare them because it's just one question. But the second question, it says look at the pattern in this chart. So I personally don't like it when the chart looks like this. So what I would rather do is I'm going to just rewrite it as a table that's vertical as opposed to horizontal. And I'm going to put 1, 2, 3, 4 here for figure number 1, 2, 3, 4. And the number is going to be 3, 5, 7, and 9. It says draw a set of figures to show this pattern. So figure 1, I'll just use circles because it's easier. Figure 1, I have 3 circles. Figure 2, I have 5 circles. Figure 3, I have 7 circles. And figure 4, I have 9 circles. Okay, it's a bad pattern, but whatever, live with it. So compare your figures to partners and discuss how they are different and how they're the same. Well, I can't compare mine to yours, but if you look at your pictures that you drew, you might have used circles, you might have used squares, you might have used dots, you might have used sticks. Whatever you used, you can compare it, and that the pattern is going to be the same. They both share the table, but the pictures you might have used for it are different. Question 3 says Chad makes up the following number pattern: 1.8, 1.5, 1.2, 1.9, ... He tells everyone that his pattern is difficult, and Kelly disagrees and says, no, the next 2 numbers are 0.6 and 0.3. Is she right? Why or why not? Well, she is right, because if you look at the pattern, he's going down 3/10 each time. He's going down 3/10. So if you go down 3/10 from here, you have 0.6, and then you have 0.3. So it is pretty easy. And the last number would be 0. But if you tried to get the next number, you'd have to understand integers, and you have to know that the next number would be negative 0.3. So I guess technically it's a little bit difficult if you're not very good with negative numbers. Now we get into some meat and potatoes questions. It says, question 5 says, describe the pattern with squares. So the first thing I'm going to do is I'm just going to see if I can make a table with this, just to see if I can organize my data. Figure 1, 3 squares. Figure 2, 5 squares. Figure 3 is 7 squares. It says draw figure 4. And really, if I was to cover up, take a square here, a white square. Let's take a white square. And then I was to cover up this part right here, we'd see that all I'm really doing is I'm adding 2 squares each time. So there's the original, there's the next one, and there's the next one. So I'm simply adding 2 squares each time, which means the fourth figure would be something like this. That's the world's worst drawing, but you get the idea. So the fourth figure, if I was to complete the table, would have 9 squares in it. Question 6 says describe the pattern of dots. Well, describing it means with each figure, I increase my pattern by 3 more dots, or adding 3. Different ways you could say it. I'm just going to say it like that. And how many dots would be in figure 5? Well, what I'd like to do is just kind of make this table again and put figure and D for dots. Figure 1 is 3 dots. Figure 2 is 6. Figure 3 is 9. Figure 4 would be 12. And if I was to complete this table, figure 5 would be 15 dots. And I use my table to get that information. Question 9, it gives you 4 different patterns, asks you to finish the pattern. So from 1200 to 800 is subtracting 400. I'm not sure, and to 0. So every time I'm subtracting 400, which means that if I put 400 there, it does make sense that I'd be subtracting 400 to go from 400 to 0, and from 800 to 400. So the answer for that missing square is 400. 1.3 to 2.4, I'm adding 1.1. Here I'm also adding 1.1, so if the pattern continues and I add 1.1, that should be 4.6. And it makes sense because if I add 1.1 again, I have 5.7. So the missing number is 4.6. A 3-sided figure to a 4-sided figure to a blank-sided figure to a 6-sided figure means that this one has to be a 5-sided figure, also known as a pentagon or a house. And the last one, there are 3 squares, 4 squares, 5 squares, 6 squares, 7 squares. That's all you had to do. That's a pretty easy question. Question 10 says the numbers in each row of the table form a pattern. In each row form a pattern. Copy and complete the table. So if this forms a pattern, this must be 1 and this must be 2. That must be 3. That must be 4. This must be 10. This must be 20. This must be 30. This must be 40. This must be 100. This must be 200, 300, 400. And finally, 1,000, 2,000, 3,000, 4,000. It says describe each pattern in rows A, B, C, and D from left to right. If you look for A, it increases by 1 each time. Increases by 1, increases by 10, increases by 100, and increases by 1,000. That's pretty easy as well. Question 12, we get a little bit more difficult here. It says this table shows fractions and their decimal equivalents. Describe any patterns you see in the table. Well, the first pattern is as I go down the fraction column, my numerator increases by 1 and my denominator stays the same. That's one pattern. Down the other one, we can say as we go down the decimal number column, the number in the 10th place increases by 1. More importantly, if I look across this way, I see that whatever my numerator is in my fraction, that's the part of my 10th position that repeats to infinity. So with 3 in the numerator, it repeats to infinity. With 4 in my numerator, it repeats to infinity, and so on. So without knowing it, what would be the decimal equivalent of 8/9? Well, if this 3 makes it into 0.3 repeating, then 8/9 must be 0.8 repeating. And interestingly enough, 0.9 repeating must be like this, but we already know that this is 1. 1 is 9/9, so 1 must also be equal to 0.9 repeating to infinity. That's one of the interesting truths about mathematics, the fact that 1 and 0.9 repeating must have the same value. I'm not bright enough to know why, but I know if you study it in university, you'll figure it out. Probably in high school, when you study calculus, you'll get it. Okay, and we'll go on to the next one. We won't worry about the other part. And actually, we skipped this one, didn't we? And we're done. Easy as that. Okay, take it.